Hi everyone, today we are going to learn about factoring. This is a concept that I know that you learned when you were in Algebra 1, and it's going to be one of our main focuses of the entire year. This is a skill that I need you to be very comfortable with and actually an expert in by the time that you walk out of this class. But before we get started, I would like you to please go ahead and do this really quick warm-up. I would like you to please rewrite f of x equals 3 times x minus 4 times x plus 5 in standard form. So go ahead and pause the video and rewrite this function so that it is in standard form. That means to get rid of all of the parentheses. And when you're finished, go ahead and restart the video. All right, let's go ahead and see how well you did. So I'm going to start off by distributing 3 to each term. And I end up with f of x is equal to 3x minus 12. I'm going to put that into parentheses and now multiply 3x minus 12 times 5 using FOIL. So I have f of x is equal to 3x times x, which is 3x squared, 3x times 5, which is plus 15x, negative 12 times x, which is minus 12x, and negative 12 times 5, and that is equal to minus 60. So I'm going to combine my like terms in the center, and I end up with f of x equals 3x squared plus 3x minus 60. And that is our answer written in standard form. So what we're going to be doing now is we're going to receive or have expressions written in standard form, and we're now going to rewrite them back into intercept form. And by doing that, by going back and forth between the forms, it kind of helps us to identify key pieces of information. Like intercept form is really easy for us to identify the x-intercepts. So that's one of the reasons why we want to become experts at this skill. We want to be comfortable with going back and forth between the different forms. So our learning objectives for today, before you end with this lesson, I want you to be able to say, I can factor quadratic expressions using a variety of approaches, meaning that you can use guess and check, or you can use like an Xbox method, or that you can, some people know using the distributive property backwards. So there's a variety of approaches that you will be able to use. And I want you to be able to use factoring to solve quadratic equations, and in doing so, be able to identify your x-intercepts, which are your zeros of the function, without graphing. I also want you to be able to say, I can factor quadratic functions in standard form and rewrite them in intercept form. So that's another thing that I want you to be able to do in this unit, or in this section, excuse me. So before we get started, let's go back to the basics of the simple vocabulary that we have here. The first vocabulary word is a monomial. And a monomial is an expression that is simply a number, a variable, or a product of these. So an example would be like the number 5, the letter x, or a product of these, 5x. All of these are examples of monomials. It's just a thing, just a term is what we call a monomial, a term. A binomial is a sum of 2 monomials. So it's a sum of 2 monomials. Now please note that monomials can also be negative. I could also have negative 5 as a monomial. I could have negative 5x as a product of these. So it can be positive or negative. Now remember, whenever you see sum and you're adding negatives, that indicates that we are minusing. So even if you see minus, like x minus 5, or 5x plus 2, or negative 3x minus 7, all of those are considered monomials. I'm sorry, all of them are considered binomials, where it's a sum of 2 different binomials. A trinomial, the TRI, indicates that it's going to be a sum of 3 monomials, like x squared minus 4x plus 8. That's considered a trinomial. Now, the maximum exponent does not have to be a 2. It can be any exponent that you see, or it could be terms where all of the letters are different. It just depends on whatever situation you are given. So what we are going to do to hop right into our lesson for today is we're going to be taking two binomials, multiplying them together to end up getting our standard form. Or that's exactly what we did in our notes up here. We had ourselves two different binomials that were being multiplied together, and after they were multiplied together, we ended up with our equation in standard form. So that's exactly what we're going to do. We're going to go from factored form to expanded form, which is like intercept form to standard form. So how this happened is this. We have x minus 7 being multiplied by x plus 8. And what we do is we FOIL. We have x times x, which is x squared, x times 8, which is plus 8x, negative 7 times x, which is minus 7x, and negative 7 times 8, which is minus 56. And then notice that we have 4 terms here. This is going to become incredibly important, especially when we do factoring by grouping. We have ourselves 4 terms. And what we do is we combine our like terms in the center. So that'll give us x squared plus x minus 56. And that's how we end up with our expression, with our expanded form. So now what we're going to do is we're going to work backwards. We're going to be given our expanded form and try to figure out a way to go back to our factored form. So the reverse of this process, you can reverse this process and factor, if possible, trinomials written in the form of x squared plus bx plus c. So we're going to factor when a is equal to 1. These are the easy ones, which is really, really nice. So in order for you to factor, what we want to do is we want to figure out what's going to go inside of the parentheses. What two binomials multiplied together to equal our trinomial? So the trick is that whenever you have a equaling 1, you simply split apart the x squared into an x and an x. And then what we need to do is we need to figure out what our p and our q value are, what our x-intercepts are, what our zeros are, because that's essentially what we're trying to find of our quadratic function. So the trick is that what you want to do is you want to figure out what two numbers together add to equal b and what two numbers multiply together to equal c. So that's what this language means. What two numbers multiply together to equal c, but together add to equal b. Another approach is to create an x. We need to figure out what two numbers multiply together to equal your c value. So they together multiply to equal c, but together add to equal b. And whatever those numbers are, we call them p and q. P times q would equal c, and p plus q would equal b. So an example of this using regular numbers is that we have x squared plus 5x plus 6 can be factored into x plus 3 times x plus 2. And that is because we're looking for two numbers that when multiplied together equals our c value, and our c value is 6. And our b value is 5. We need to figure out two numbers that when together multiply to equal 6 and together add to equal 5. Those two numbers would be 3 and 2. And that's because 3 times 2 equals 6 and 3 plus 2 equals 5. So when we factor, we're going to split apart the x squared into an x and an x. And whatever the side of our x is, that's going to be our answer, plus 3 and a plus 2. And it can go into any order, the parentheses can. You could have x plus 2 first and then x plus 3. So what we want to do is we want to find two numbers whose product is c and whose sum is b. That's what we want to find. So let's go ahead and look at letter A. For letter A, we're going to start off by writing out our two parentheses. So to factor is to break it down into two parentheses. And I need to figure out what two numbers multiply together to equal x, or I'm going to split apart the x squared into an x and an x. And I need to figure out what two numbers multiply together to equal my C value, which is negative 18, but together add to equal negative 3. So I have to think about the numbers in the number 18 and think about the factors or two numbers that I know that multiply to equal 18. So I know that 1 and 18 multiply to equal 18, 2 and 9, and 3 and 6. So looking at those numbers, I need to come up with a combination, and I'm leaning more towards the 3 and the 6. I know that 3 minus 6 equals negative 3, so I'm going to try that. 3 minus 6. Is 3 times negative 6 negative 18? It is. And is 3 plus negative 6 negative 3? It is. So therefore, I'm going to write x plus 3 and x minus 6, and that is simply my factorization. I'm going to look at letter B. Letter B, I'm going to write down my two parentheses because I know that that's what my answer looks like. And I'm going to split apart the d squared into a d and a d. And that's because I know that d times d is d squared. Now I'm going to think about my situation. I need to come up with two numbers that when multiplied together equal 48, but together add to equal 14. Now this one can be a little bit trickier, so I always like to go with the factors that I work with most often. So I'm looking at this, and I know that 2 and 24 multiply to equal 48. I know that 3 and 16 multiply to equal 48. None of those are working. I know that 4 and 12 multiply to equal 48. 4 plus 12 doesn't get me 14, so that's not going to work. I'm going to look at 6 and 8. 6 plus 8 does equal 14. I think that that's my combination, so I'm going to go 6 and 8. 6 times 8 equals 48, and 6 plus 8 equals 14. Awesome. D plus 6 and D plus 8 is my factored form. Now, some of you might ask me, do you have to use this X method? No, you do not. If you know the answer right away, you don't have to show me any work at all. That's actually what my goal is. My goal is for you not to show any work with this process. But I do know that I have a lot of people who are visual learners, and for my visual learners, you need to see what the process is. So I'm just showing you how you can come up with your answer relatively quickly. Let's go ahead and look at letter C. For letter C, I'm going to break this apart into two parentheses, splitting apart my m squared into an m and an m. And I'm going to ask myself what two numbers multiply together to equal negative 63, but together add to equal 2. So whenever I think of 63, I always think of 7 and 9. I know that 7 times 9 is 63, so I'm going to put in a 7 and a 9. Now somehow I need to get a negative 63 and yet end up with a positive 2. So that tells me that my larger of the two numbers needs to be positive. So that would mean that 7 would be negative, and I'm just going to check. Negative 7 times 9 is indeed negative 63, and negative 7 plus 9 is equal to 2. So my answer is m minus 7 and m plus 9. So that is just plain factorization. The next part dealing with factorization are your special products, and you must know your special products. There's two different special products that deal with quadratics, and that is a difference of two squares and a perfect square trinomial. Both sets of special products, I need you to please make sure that you know and study. Please make sure that you know and you study these. I want you to be able to recognize that when you see a difference of two perfect squares, you are not thinking about how to solve that problem or how to factor it. You already know what that pattern is. So what I call dots, or difference of two squares, is exactly how it sounds. You're going to have a perfect square number minus a perfect square number. And the factorization is going to be the square root of the first term, and then the square root of the second term, and then inside of the middle is going to be a plus and a minus. So I'm going to take the square root of a squared. The square eliminates the square root, and I'm left with a. That's what goes into the first position. Then I'm going to take the square root of b squared. The square eliminates the square root, leaving me with the number b. That's what goes into the second position. And what changes is just the sign. We're going to have opposite signs. So for example, we have x squared minus 4. The square root of x squared is equal to x. So that's what goes into the first position, an x and an x. Then we have minus 4. And if I'm going to take the square root of 4, that is equal to 2. That number 2 goes into each position. And what two numbers multiply together to equal a negative? Well, a positive number times a negative number. And so that's the reason why we have opposite signs. And that is considered a difference of two squares. So in example letter A, we have ourselves a difference of two perfect squares. So in order for us to factor it, I'm going to take the square root of m squared. That's going to equal m. And so that goes into our first position. Next, I'm going to take the square root of 121. And the square root of 121 is equal to 11. So 11 will go into the second position. And how do you get a negative? A positive times a negative. And that's your factorization. That is all you need to do. You do not even need to show me this work down here. This is extra work for those of you who need to see how you get the answer. Another approach is you could also rewrite this as m squared plus 0m minus 121 and do the x thing. You could have also said what two numbers multiply to equal negative 121, but together add to equal 0 and get a negative 11 and a positive 11, but I personally think that that's too much work. Just know the pattern and call it a day. So that's our first pattern. Our second pattern is a perfect square trinomial, and that is another pattern that you will be expected to know, especially whenever we are solving quadratic equations by completing the square. That's going to be one of the processes that you will be expected to know, and perfect square trinomials is one of the things that you absolutely need to use in order to solve by completing the square. But in the meantime, let's go ahead and talk about what a perfect square trinomial is. Well, for the most part, it's exactly how it sounds. You're going to have a trinomial in which different pieces of it will be perfect squares. You'll have the structure a squared plus 2 times ab plus b squared, or a squared minus 2ab equals b squared, plus b squared, and both of those are going to equal a binomial. So that is a plus b squared and a minus b squared. So for example, we have x squared plus 6x plus 9. In this problem, notice that the first term and the last term is a perfect square number. So what you do in order for you to verify that this is a perfect PST is you take the square root of your first term, that's going to be x, and you take the square root of your second term, the square root of 9 is 3, and then you check. The 2ab part is the middle. 2 times a times b is the middle 2 times x times 3. So we're going to go 2 times x times 3, because remember a and b is the square root of a squared and b squared. So 2 times x times 3 is equal to 6x. So is the middle term 6x? Yes, it is. So that's how we know we have ourselves a perfect square trinomial. The number 3 is simply the square root of c, square root of your last number, the square root of your c value. For the next one, I'm going to take the square root of x squared, that's going to be equal to x, and the square root of a positive 4, that's my c value, that's equal to 2, and then I'm going to check, is 2 times x times 2 equal to 4x? And indeed it is. And notice that it's a minus. So inside of the parentheses, this is going to be the sign of b. So our b value is positive in the first example. We have a plus sign. If your b value is a minus, we will have a minus sign in your parentheses. So what I'm going to do is the long way for letter B, and then I'm going to show you why the shortcut is so much better. So for letter B, the long way is to say, oh, I'm going to split this apart into 2 parentheses, making that, splitting up the r squared into an r and an r. Then I'm going to figure out what 2 numbers multiply together to equal 49, but together add to equal 14. So some of you might say, oh, I know 49, that's 7 times 7. And I know 7 plus 7 is 14. Awesome. So that's going to be r plus 7 times r plus 7. And these two parentheses are exactly the same. So your final answer is simply r plus 7 squared. So some of you might really like that process, and that's really awesome, but it's not going to be nearly as easy once we have a perfect square trinomial when your a value is not equal to 1. Once we get an a value that's not equal to 1, it becomes a little bit more intense. But while you're learning these types of problems, if you need to go about it using that structure, you're more than welcome to. Let's go ahead and look at letter C. For letter C, this is a perfect square trinomial. So what you would simply do is recognize that this is a perfect square trinomial by saying the square root of p squared is equal to p. The square root of 144 is equal to 12. And I know that 2 times 12 times p is equal to 24p. Cool, that's my center. My center is a minus, so my answer is p minus 12. Done. So like I said, some people, this is just too much. It becomes, you're just not there yet. My goal is for you to be there by the time we end this unit, because perfect square trinomials are not going away this year. We'll be focusing on them the entire year. All right, let's go ahead and flip the page, you guys. Let me zoom out so you can actually read what's going on. Here we go. So now we're going to solve quadratic equations, and you can solve quadratic equations, or you can use factoring to solve certain quadratic equations. So we can factor only the ones that are factorable. So a quadratic equation in one variable can be written as ax squared plus bx plus c equals 0. And that happens where a is not equal to 0. This is considered standard form. And the solutions of the quadratic equation are called the roots of the equation. The roots of the equation are also known as the zeros of the equation, which are also known as the x-intercepts of the equation. So roots, zeros, x-intercepts all mean the exact same thing, and you will see that over and over again. And it only works if you're solving a quadratic equation that is equal to 0. So it must equal 0. If you see an equation that is quadratic that's not equal to 0, then you need to do some rearranging of your terms in order to make sure that at least one side is equal to 0. Now, if the left side of x squared plus bx plus c equals 0 can be factored, then the equation can be solved using the zero product property. And what the zero product property means is that if you have two expressions, let's call them a and b, and we have a times b is equal to 0, like two parentheses when multiplied together equals 0, then either a equals 0 or b equals 0. Either the first expression equals 0 or the second expression equals 0. So in a nutshell, if you have a factored form equation, what you'll do is you'll set each parenthesis equal to 0, and then you'll solve for x. So in this problem, we have x plus 5 times x plus 2 equals 0. In order to solve this equation in factored form, you're going to set each parenthesis equal to 0. So we have x plus 5 equals 0 and x plus 2 equals 0. Then when you subtract 5 on both sides and you get x alone, you'll end up with x equals negative 5. And when you subtract 2 on both sides, you'll end up with x equals negative 2. You do not need to show me the setup of the two equations. If you can simply see that it's your x-intercepts are going to be the opposite of what you see inside of the parentheses of negative 5 and negative 2, you're good to go. And what x equals negative 5 and x equals negative 2 mean? They're your x-intercepts. They're the location on the graph where your parabola crosses the x-axis. So let's go ahead and look at example number 3. In example number 3, I don't want you to lose your equal 0. You need to make sure that you keep that equal 0 as a part of your equation. So I'm going to start off by breaking down the left-hand side of the equation into 2 parentheses by splitting apart the x squared into an x and an x. And from there, I'm going to ask myself, what 2 numbers multiply together to equal negative 42, but together add to equal negative 1, which is my b value. And whenever I think of 42, I always think of 6 and 7. And I know that, so I'm going to put down 6 and 7, because I know that they're only one term apart from each other. So I want it to be a negative 1, so that means that I need 7 to be negative. 6 times negative 7 equals negative 42, and 6 plus negative 7 equals negative 1. So I'm going to have an x plus 6 and an x minus 7. So the shortcut is to simply say, what's the opposite of a minus 6? I'm sorry, what's the opposite of a plus 6? A minus 6, so x equals negative 6. And what's the opposite of a minus 7? A positive 7. So x equals negative 6 or x equals positive 7 is our answers. And so therefore, our x-intercepts are going to be negative 6, 0 and 7, 0. These are our x-intercepts. You may ask me what structure I want your answer to be written in, and either structure is perfectly fine with me. You might be asked to identify your x-intercepts, and whenever you're asked to identify x-intercepts, we always write them as ordered pairs. But if you're simply asked to come up with a solution, if you write it as negative 6 and 7, the way that I have it written up here, that's fine too. All right. So looking at example number 4, we want to figure out what are the roots of the equation. So the roots of the equation is the same as finding the x-intercepts, which is the same as finding a 0. What we need to do first is we need to change this equation so that it's equal to 0. So I'm going to start off by subtracting 35 on both sides. And now I end up with x squared plus 2x minus 35 equals 0. So now we're going to factor this equation and identify what our roots are. So I'm going to let you go ahead and complete example number 4 and example number 5 on your own. So go ahead and pause the video and solve both of those problems on your own. And when you're ready, go ahead and restart the video. All right, let's go ahead and see how well you did. So hopefully you were able to start off by breaking this equation down into 2 parentheses and splitting apart the x squared into an x and an x, and asking yourself what 2 numbers multiply together to equal 35, but together add to equal 2. And hopefully you were able to see that 5 and 7 multiply to equal 35, and since we want it to end up with a positive 2, I'm going to have a negative 5 and a positive 7. So we'll have x minus 5 and an x plus 7. So our roots are going to be x equals 5 or x equals negative 7, the opposite of what we see. And our x-intercepts are going to be 5, 0 and negative 7, 0. Let's go ahead and solve the next equation. This is considered a dot situation, a difference of 2 squares. So hopefully you were able to break it down into 2 parentheses very easily. Splitting apart the f squared into an f and an f. The square root of 121 is 11 and an 11. And we're going to have a plus and a minus inside of our parentheses. So that means that f is going to be equal to negative 11 or f is going to be equal to positive 11. And our x-intercepts in this case would be negative 11, 0 and 11, 0. And that is simply your answer. All right, let's go ahead and flip to the next page. Flip to the next page. All right, so we have right here the zeros of a function. So notice that I've used the word zeros, roots, and x-intercepts. So I'm going to write that down right here. Roots, zeros, x-intercepts, all imply the same meaning. It just depends on if we're trying to identify the x-intercepts, if we're solving simply an equation. It just depends on what's going on. But if you see all three of those words, all three of those terms, they all imply the same meaning. Find the x-intercept. Find the location on the graph when y is equal to 0. So the x-intercepts of the graph y is equal to a times x minus p times x minus q are p and q, because this is our intercept form. This is our intercept form of a quadratic function. So because the function's value is 0, because we have to set the function equal to 0 when x is equal to p and when x is equal to q, the numbers p and q are called the zeros of the function. So because the function's value is 0 when x equals p and when x equals q, the numbers p and q are called the zeros of the function, the roots of the equation, the x-intercepts of the parabola. They all indicate the same exact thing. So if you are asked to find the zeros of the function by rewriting the function into intercept form first, we're simply going to start off by replacing that y equals with the number 0, and then breaking down the quadratic into two parentheses. So I'm going to split apart the x squared into an x and an x, and I'm going to ask myself, what two numbers multiply together to equal negative 28, that's my c value, but together add to equal 3. Now, whenever I think of 28, I always think of 4 and 7. So I'm going to put down 4 and 7, and I want it to end up being a positive 3, so I'm going to make 4 negative. Negative 4 times 7 is negative 28, and negative 4 plus 7 is equal to positive 3. So I have x minus 4 and x plus 7. So my zeros of the function are x equals 4 or x equals negative 7. And we can write that as 4, 0 and negative 7, 0. Those are our x-intercepts. All right, let's go ahead and look at letter B. For letter B, we have x squared minus 4x plus 4. And what I notice here is that my first term is a perfect square number. My last term is a perfect square number. So this is actually a PST. This is a perfect square trinomial. So I'm going to start off by replacing y with the number 0. And since this is a perfect square trinomial, all I'm going to do is take the square root of the first term. Square root of x squared is x. The square root of the last term, which is 2, and the sign of the middle, which is minus squared. So we have 0 minus 2 squared. This is the only parenthesis that we see. So therefore, our only x-intercept is x equal 2. Our only 0 is x equals 2. And therefore, 2, 0 is our x-intercept. On letter C, once again, we have our first term is a perfect square number, our last term is a perfect square number, and this is a PST, perfect square trinomial. So I'm going to replace f of x with the number 0, and I'm going to write a parenthesis squared, and inside of the parenthesis squared, I'm going to write the square root of x squared, which is x, the square root of 25, which is 5, and the sign of the middle term, which is a minus. Once again, since this is only one parenthesis, we only have one 0, and that's going to be 5. So our x-intercept would be located at 5, 0. We have two more examples for this lesson, and they are application problems. The first one, for example number 7, is we are asked to find the value of x, given that the area of the rectangle is 36. Now remember that the area of a rectangle is length times width, or base times height, depending on how you approach the problem. But regardless, let's just say that we're going with length times width. I'll say that x plus 5 is equal to my length, and x is equal to my width, and my area is equal to 36. So I'm going to replace all of these terms into my formula for area, and I'm going to write this as 36 is equal to x plus 5 times x. At this step, I'm going to distribute that x to each term, and I'm going to write 36 is equal to x squared plus 5x. Now this is a quadratic equation, and in order for us to solve quadratic equations, we need it to equal 0. So I'm going to subtract 36 on each side. So I have 0 is equal to x squared plus 5x minus 36. So now I'm going to factor this quadratic by splitting apart the x squared into an x and an x, and asking myself what two numbers multiply together to equal negative 36, but together add to equal 5. So there's a lot of things that you can think about whenever it comes to the number 36. A lot of people think of 6 and 6 first, but that's not going to work. So there's 2 and 18, 3 and 12. None of those will give me a 5. There is 4 and 9, and I know that 4 and 9 are 5 units apart from each other, so I'm going to use 4 and 9. And thinking about two numbers, we want a positive 5, so that tells me that I need 4 to be negative. Because negative 4 plus 9 is equal to positive 5, and negative 4 times 9 is equal to negative 36. So I'm going to write x minus 4 and x plus 9. So my solutions would be x equals 4 or x equals negative 9. But since we're talking about an actual area or a length, I don't think that x equals 9 is going to make very much sense. So you cannot have a negative length right here. So since you cannot have a negative length, that indicates that x is equal to 4 is our only solution for x. Last example, here we go. So it says you have a vegetable garden in your backyard that measures 15 feet by 10 feet. You want to double the area of the garden by adding the same distance, we'll call it x, to the length and the width of the garden. Find the value of x and the dimensions of the garden. Well, this problem is really tough without a visual, without a picture. So what I would recommend that you do is you draw a quick picture, draw a quick sketch of what's going on here. So one side of this is going to be 10 feet, one side is going to be 15 feet, and this is our original garden. And what we want to do is we want to double the area. So that's something that we need to do. We want to double the area of the garden by adding the same distance x. So we're adding some distance x to the length and the width of the garden. So I'm going to add some distance x to the length and to the width of the garden. So that would indicate that our new garden would look like this. So it goes from 150 square feet. So if I were to multiply 10 times 15, I would start off being 150 square feet. And if we want to double the area, we want our new area to equal 300 square feet. So what we need to do is we need to figure out what should the value of x be and what should our new length and new width be. So I need to figure out what my new length is, my new width, and what x is. So that's what I need to know. That's what I'm trying to find. So area is, we want our new area to be double the amount that we already had. So that means that I need to multiply the length and width together. So what I'm going to do is I'm going to add 10 feet in x and 15 feet in x to come up with my expressions to represent the length and the width. So I'm going to rearrange this so that x comes first, and I'm going to write 300 is equal to x plus 10 times x plus 15. So now I'm going to use FOIL, and I'm going to write 300 is equal to x squared plus 15x plus 10x plus 150. Now I'm going to combine my like terms in the center, and since this is a quadratic equation, I need my quadratic equation to equal 0, so I'm going to subtract 300 on each side. So I'm going to do multiple steps in one step, and by making that 0 equals x squared plus 25x minus 150 minus 300 is minus 150. Now I'm going to factor this quadratic equation, or factor in order to solve for this quadratic equation, by splitting apart the x squared into an x and an x. And I need to figure out what two numbers multiply to equal 150, but together add to equal 25. So what I'm going to do is I'm going to look at the numbers that I know. I'm allowed to use a scientific calculator. So you might want to have a scientific calculator out and start by dividing. 150 divided by 2 is equal to 75. So let's check out, does 2 and 75, can we get a 25 somehow from that? The answer is no. So now I'm going to take 150 and divide it by 3. And when you divide 150 by 3, you end up with 50. But 3 plus 50 minus 50, there's no way for us to get a 25. And when you go 150 divided by 4, it doesn't work. So I'm going to try 150 divided by 5. And when I do that, I end up with 30. And I know that 30 minus 5 is equal to 25, so I think we found our combination that works. So I'm going to write negative 150 and 25. So two numbers that when multiplied together equal negative 150, but together add equal 25. Well, I'm going to have 5 and 30, but I need it to be a positive 25. So I'm going to make 5 negative. So I'm going to write x minus 5 and x plus 30. So our solutions are x equals 5 or x equals negative 30. But unfortunately, we can't have a negative length. You can't add negative 30 to this. So therefore, our answer is x equals 5 feet. Our units are feet. So we have x equals 5 feet. So our new length is going to be 10 plus 5, which is 15 feet. And our new width is 15 plus 5, which is 20 feet. And that is our answer. We've just addressed this question. If you have any questions over anything, please feel free to email me. This is the end of the lesson, and I will talk to you next time.